Hello students, welcome to analysis of indeterminate structure class. Let us take one more problem. This is the problem given here. The problem is analyze the continuous beam by slope deflection method. The support B and C sinks by 8 mm and 3 mm. That means the support B sinks 8 mm and support C sinks 3 mm respectively. Take EI is equal to 20,000 kilonewton meter square. In this problem, the EI full value given here. You can, in the place of EI, you can directly substitute this value. Okay. The continuous beam line diagram is given. Three spans are there: AB, BC and CD. Span AB, consider span AB. There is no any applied load on the span AB. Considering span BC, uniformly distributed load is there, that is given 20 kilonewton per meter, and the span is 8 meter. And considering span CD, there is no any applied load. Considering the joints, support A is fixed support, and support B is roller, C is roller, and D is fixed support. Sorry, support A is pinned support. This is pinned support, and support D is fixed support. And here the I value is given in number of times. That means for span AB, for particularly span AB, the I you can consider 1.5 times. Okay, just in the place of I you can substitute 1.5 I. Okay, and for span BC 2I, the value is given 2I, and for span CD just I or 1I. Okay, and next take solution. According to the given line diagram and according to the given data, you can consider the support sinks. That means support B sink 8 mm and support C sink 3 mm. But you can recall once again last problem, whatever we did last problem, there just one support is sink, but here two supports are synced. So that is the difference, main difference here for last problem to this problem. Here two supports are sinks. So in this type problem, how we are going to consider the del or do? Let us see. We know the sign convention already. For considering support B, consider the left hand side take positive and right hand side take negative. For sinking, that means the do value or del value consider positive towards left hand side and consider negative towards right hand side. This is the sign convention. It is clear. Now the support B sinks 8 mm. That means considering left hand side 8 mm, it is correct. You can directly take the 8 mm and you can convert to meter. It is 0.008 meter. But considering right hand side, the support C effect also is there here in this span BC. What happens in this condition? just you can add both the sink. How we are going to add? Considering support B, by take right hand side. What is the sign convention here? Minus 8 millimeter. Coming here, that means joint C. Considering left hand side, what is the sign convention? Positive. That means 3 millimeter. The sink on the span C is 3 millimeter. So the sign convention is plus. That means you are adding these both the value. That means minus 8 millimeter plus 3 millimeter. You are getting minus 5 millimeter. It is so simple. After you are going to convert to meter, it is 0.005 meter minus 0.005 meter. This is the value you should take for span BC, the settlement or sink value. That means dou value. Next, considering support C right hand side, the dou value is minus 0.003 meter. It is clear. Okay. Next, take one by one steps. The first step is fixed end moment calculation. For calculating fixed end moment, here you can observe moment, fixed end moment AB, fixed end moment BA, fixed end moment CD, fixed end moment DC. Is equal to 0. Why is this is equal, the fixed end moment of these span are is equal to 0? Anybody think about that? You can observe the line diagram. On the span AB, there is any load is there? Any load is there? No. And span CD, there any load is there? No. Then how you are going to calculate the fixed end moment? It is not possible. So no any load, so there is no any fixed end moment. Though so simple. Okay. So that's why fixed end moment AB, BA, CD, DC, those are all are equal to 0. Okay, next, considering fixed end moment BC, but on the span BC the load is given, UDL is given 20 kilonewton per meter. So you can use the load and calculate according to the load condition. UDL is there, so the formula is minus WL square by 12. So after substituting, you are getting minus 106.66 kilonewton meter. Similarly, for fixed end moment CD, you are getting this answer. Okay. Next step is applying slope deflection equation. How we are going to apply the slope deflection equation? Theta D equal to 0. Why theta D equal to 0? The support D is fixed support, so there no any slope. That means theta is equal to 0. Theta D is equal to 0. After, by using slope deflection equation, you can calculate moment AB. Here directly substituted. You can observe 2EI. In the place of EI, you should substitute the given EI value and also the given I value also. That means here on the span AB, the I value is given 1.5 times, so that is the reason here multiplied 1.5 into the EI value is 20 into 10 raised to 3. Okay, and the remaining here the dou value is 0.008, and substitute the values and calculate or simplify this equation, and so after you are getting this equation number 1. Theta and theta b is not equal to 0 because the support conditions are not fixed, so you can keep it as it is. Similarly, calculate the moment BA. How we are going to calculate? By using slope deflection equation, you can substitute the data and simplify this equation. You are getting equation number 2. Similarly, calculate the fixed end moment BC. You are getting equation number 3. Yes, in the span BA also the del or dou value is 0.008 millimeter, and considering span BC, yes, we already discussed about this dou value. The dou is minus 0.005, and similarly for CB also minus 0.005. okay, and after simplifying this you are getting equation 4, and similarly calculate by using slope deflection equation moment CD. How we are going to calculate? By using slope deflection equation. Here actually I directly substituted. You should always write one more time the slope deflection equation here. Okay, that is actually a good habit. If you are writing every time, every step, the slope deflection full equation, then that will remember very long time. That means it will help in your exam time. Okay, you are not going to forget easily. And what is after considering span CD, for calculating moment CD, the dou value is minus 0.003. okay, and also here considering here 2 is there, so why 2? Because there 2i is given, and here 1 is there. Why? There just 1 I is given, so here wrote 1. okay, and after simplifying you are getting equation number 5, and similarly calculate the moment DC. You are getting equation number 6. okay, next step we will discuss next video. Let us stop. Okay, happy learning. Thank you.